moving to the next part, let's understand uh, a bit about Docker architecture and the terminologies that will be useful for us while understanding about Docker. So as you can see, this is a client where it provides the functionalities like Docker build, Docker pull, Docker run, and there is a Docker host. It will be hosted in the machine where you will be running the containers from images, and this is registry. So registry is a place. So let's understand each terminology bit by bit. The Docker daemon. The Docker daemon listens to the Docker API request and manages Docker objects such as images. So the Docker daemon just communicates with the client, and uh, once the image is formed, uh, it maintains the images, it maintains the container on which the images are run. So it is basically the similar to like a CPU of a computer. So it manages each and everything, the Docker daemon, and due to which the every uh, process that is happening in the Docker host is uh, carried out. Moving to the Docker client, let's learn about it. So Docker client is also known as Docker, is and it is the primary way in by which you can communicate with the Docker host. Like there is a machine placed somewhere else in cloud where you want to run the particular image, or you want to form a container of a particular image. So you will be communicating by a client with the help of commands like docker build, docker pull, docker run, which will be initiated, like which will be run on docker daemon, and this docker daemon will like do the required process whatever you want. Either you want to build a docker, either you want to pull, or either you want to run the uh, image on any container. So that's how the function of Docker client is. It helps us to communicate with the Docker host, and it can communicate to multiple Docker hosts. Either you want to communicate with the Docker 1, uh, or either with the Docker 2, like Docker host 1 or the either Docker host 2. So that is the primary functionality of client. Now Docker registry. The Docker registry stores the Docker images. Uh, Docker Hub is public registry that anyone can use. So the Docker has provided a pool, you can say, where the images are given, or images are stored, and uh, you can use those images in your local machine by pulling them, or while you are using the Docker in your computer, you can also push to your own private registry by forming the images. So let's say if you want to pull some images from the public repository, you can make some changes onto it and push it in your private registry, and it like it helps us to form the layer, or to from the layer over the public registry that was already available. So it is bit easy, and the cost of doing is cheaper, as you are not building something from your scratch. You are using the already available image, and you are just updating their feature and like using it through. So it and every image is stored in the registry. So that is the purpose of Docker registry. So let's talk about what are images. Images is a read only template with instruction for creating a Docker container. So as I have mentioned earlier, while creating an container, you will use image, similar to like a class concept where images is used to create multiple containers. In the same way, the class is used to create multiple objects and use them in the code. So like what about the images? So often we can use the images that are present in Docker registry with some additional customization. For example, if you want to build an image which is based on Ubuntu image, like if you are using a Ubuntu image that is already provided in Docker registry with some Apache web server or your some dependencies specific to your application, you can add them and run the image. So what the changes will happen, the Docker file creates a layer on the image. So when you change the Docker file and rebuild the image, only those layer which have changed are rebuilt. So the layers that are changed, that will be rebuilt. So it's a very lightweight, you can say, and the process will be simple and super fast as compared to other visualization virtualization technique where everything will be stacked on and rebuilt. So it is something where you are just stacking a functionality as a layer and not changing or building the whole image. Let's talk about containers. A container is a runnable instance of an image, as similar to how we were creating an object of any class in either Java or C++. In a similar way, you can create containers that is a runnable instance of an image. So you can create as many containers as you want of a particular image, and once you create an instance, you can create, stop, move, delete, or do any operation whatever you want. A container is a runnable instance of an image. You like similar way when we create a object of a class in C++ or Java, in a similar way you can create a runnable instance of any image that is called a container. So you can create as many as instance you want of an image, and you can do any operation like create an container, start a container, stop or move or delete anything whatever you want through either API or CLI. And those containers that are created of a particular image are well isolated from each other. So the one container that is formed from an image will not have any effect to the other container. So and how in the granular level they can be controlled is like you can either uh, control the network or the storage or many more things like of one container from the other container, means the effect or the network storage of one container would be different from the other. You can have every control over it. So that is the benefit of Docker. Like let's say if you screwed up or if the functionalities of one machine like is down, one container is down, the other containers will have no effect on it and they will be running perfectly fine. So uh, what happens when we delete a particular container? So the changes that are not stored will already disappear. So this is how the what is container and what is the concept of container. What happens when we run this particular command? So when we run this docker run -i -t ubuntu /bin/bash. So what happens? So it will if let's say if you don't have an image, ubuntu image, so it will so this command will be using ubuntu image. So before doing this, you should have ubuntu image in your local. So to get ubuntu image in your local, you can run docker pull ubuntu, and once the image is being pulled, you can create a container out of it. So as we know, like images cannot be run directly. You have to make a container of them. And once the container is created, once you create a container, the Docker will allow or allocate you the read write file system to the container. And that read write file system will be provided as its final layer, as the create or modify files to the directory in local system will be easy, as we have already seen. We have seen in the image part when we were understanding here. why images are so lightweight and so fast? Because everything or changes that are made in the final layer, not in the whole image. So whenever the container is made, uh, we are given the read and write file system to the container as its final layer. So we can see visually what will happen through the diagram once. And let's delete this. Yeah, so we can see when we run the client, when we run these commands through the client, the commands will be given to the docker host, and the docker host will see the commands through the docker daemon. And let's say if the images are present locally, it will form a container. If not, the docker daemon will talk to registry, fetches the image through there, and form the container. So if the image is present locally, it will form the container directly. If not, it will fetch from the registry and then form a container. So that's how the overview of Docker and client is. Now we will move on to the coding part, where we will be taking about some exercises and run through the Python code. Thank you for viewing till end. To all my supercomputers, hashtag be lazy. That's how supercomputer efficiency is increased. Please like, share, and subscribe. Isa la kapna apte.